Now we're looking at another double integral, but this is slightly different than before, because before I had a constant to a constant. The limits of integration were, it was like 0 to 5, and that would be 0 to 7 or something like that. Now that's not a constant, that's a variable x. So how do we do that? Well, we just do our regular stuff. We integrate this here, x plus y, that's the function, that's f, and we integrate that, in this case, with respect to y. And remember, as far as y is concerned, the x here is a constant. So I get that x just grows a y, and that y becomes y squared over 2. And again, y is going from 0 to x. So I'm going to, instead of plugging in like a constant into the y, I'm going to plug an x into the y. So this is going to become, that y turns into an x, and that y squared turns into an x squared. So it becomes x times x plus x squared over 2. Of course, minus 0 minus 0. But this is really x squared, that's x squared over 2. So this is really just 3 halves x squared. And the integral of 3 halves, and now it's a very simple, straightforward integral. An integral of 3 halves x squared, that's just x cubed over 2 between 0 and 7. And that just becomes 7 cubed over 2 minus 0. 7 cubed is 343. And that's my final answer. This integral is equal to 343 over 2. But now the question is, what does that region look like? What does the region look like here? See, because if it's a 3 to 5 and 0 to 7 or something like that, then I know that's a rectangle. That's straightforward. But what does that x do? So here's what it does. Y is going between the curve x equals 0 and the curve y equals 0 and the curve y equals x. Whereas x is just going unfettered from 0 to 7. So x is going from 0 to 7, but y is going from 0 up to x. So y just goes from 0 up to x, and that winds up becoming now this whole triangle here. This whole triangle winds up being the region over which this function is hovering, and we're taking the integral. And that is how we do that.